Square root of natural numbers. In this module, you will learn how to make a square root spiral of natural numbers by paper folding. Recall that Pythagoras' theorem states that the square of the hypotenuse of a right triangle is equal to the sum of the squares of its two legs. Also, if we are given a line segment AB on a sheet of paper and C is any point on it, then to find the perpendicular at C, first fold the sheet along AB. Then make the other fold through C so that B moves along BA till the fold passes through C. The second crease formed is perpendicular to AB at the point C on it. We'll use this information to make a square root spiral of natural numbers by paper folding. For the activity, we need a sheet of paper, 2 sketch pens, red and blue, a pencil, and a ruler. On the sheet, mark a point O. From O, draw a line segment of length 1 unit and name it OP. Fold the sheet along OP so that a crease is formed along OP. Now make the other fold through P to form the other crease perpendicular to OP. Unfold the sheet completely. From P, draw a line segment of unit length on the other crease so that its two end points are P and P1. Join OP1. Applying the Pythagoras theorem to the triangle OPP1, we get the length of OP1 is the square root of 2 units. Next, fold the sheet along OP1 so that the first crease is formed along OP1. Make the other fold through P1 to form the other crease perpendicular to the first crease. Unfold the sheet completely. From P1, draw a line segment of unit length on the other crease so that its two endpoints are P1 and P2. Join OP2. Applying the Pythagoras theorem to the triangle OP1P2, we get the length of OP2 is the square root of 3 units. Now fold the sheet along OP2 to form a crease along OP2. Next, make the other fold through P2 to form the other crease perpendicular to the previous crease. Unfold the sheet completely. From P2, draw a line segment of unit length on the other crease so that its two endpoints are P2 and P3. Join OP3. Applying the Pythagoras theorem to the triangle OP2P3, we get the length of OP3 is the square root of 4 units. Now fold the sheet along OP3 so that a crease forms along OP3. Next, make another fold to form another crease through P3 perpendicular to the previous crease. Unfold the sheet completely. From P3, draw a line segment of unit length on the other crease so that its two endpoints are P3 and P4. Join OP4. Applying the Pythagoras theorem to the triangle OP3P4, we get the length of OP4 is the square root of 5 units. Now fold the sheet along OP4 so that a crease forms along OP4. Next, make the other fold through P4 to form the other crease perpendicular to OP4. Unfold the sheet completely. From P4, draw a line segment of unit length on the other crease so that its two endpoints are P4 and P5. Join OP5. Applying the Pythagoras theorem to the triangle OP4P5, we get length of OP5 is square root of 6 units. Now fold the sheet along OP5 so that a crease is formed along OP5. Next, make the other fold through P5 to form the other crease perpendicular to OP5. Unfold the sheet completely. From P5, draw a line segment of unit length on the other crease so that its two endpoints are P5 and P6. Join OP6. Applying the Pythagoras theorem to the triangle OP5P6, we get the length of OP6 is the square root of 7 units. Now fold the sheet along OP6 so that a crease is formed along OP6. Next, make the other fold through P6 to form the other crease perpendicular to OP6. Unfold the sheet completely. From P6, draw a line segment of unit length on the other crease so that its two endpoints are P6 and P7. Join OP7. Applying the Pythagoras theorem to the triangle OP6P7, we get the length of OP7 is the square root of 8 units. Now fold the sheet along OP7 so that a crease is formed along OP7. Next, make the other fold through P7 to form the other crease perpendicular to OP7. Unfold the sheet completely. From P7, draw a line segment of unit length on the other crease so that its two endpoints are P7 and P8. Join OP8. Applying the Pythagoras theorem to the triangle OP7P8, we get the length of OP8 is the square root of 9 units. Now fold the sheet along OP8 so that a crease is formed along OP8. Next, make the other fold through P8 to form the other crease perpendicular to OP8. Unfold the sheet completely. From P8, draw a line segment of unit length on the other crease so that its two endpoints are P8 and P9. Join OP9. Applying the Pythagoras theorem to the triangle OP8P9, we get the length of OP9 is the square root of 10 units. We can see that the red line segments represent the square root of the first 10 natural numbers. Also, the shape formed by the blue line segments is a square root spiral. In this module, you have learned how to make a square root spiral of natural numbers by paper folding.